Okay, Assalamualaikum and good morning. I guess we can start our session. It's already 8 a.m. Okay, so today we are going to go into chapter 4, the end of our chapters in this semester. But before we do that, I would like to show to you how to prepare the QSUM chart using Excel to get the what you call that the regression equation for your what do you call that energy saving energy consumption relationship for the whole reporting period lah. So I believe you guys can see the how to plot QSUM chart from your Google Drive. Let me double check on that. Hold on, yeah. EPO626. While we wait for your friend to join us. What's the link? Let me see it. Oh, I didn't put it in here. Okay, never mind. I'll add it in now. Hold on here. Automation plug. Give me a second. Okay. Okay. Where is it? Oh, never mind. Tapi ni, I've added the how to plot QSIM chart here for you to refer to after this. Especially this is going to help you for your video project later on. The words file here. So while I'm showing you how to do it, you can also download this or maybe just open it from your Google browser or from your browser and then try to do it as well. Sorry. So in order for you to do this, you need to have your Excel file being open. It can be just a new file, and then you need the first thing is you need to copy all this into your Excel, which I'm suppose I need to show to you. Okay, this one. So just paste the data. Of course, you need the data. You can't plot anything if you don't have data. So okay, so the data here is being given from, I guess, from internet. This data is from the internet. So as mentioned, or for your mini project, we are working on getting your supposedly working data from BPF, but so far I haven't get any update yet. But if not, if we are unable to get that from them, chances are you guys need to go to the internet to get this kind of data, something like this. So as you can see, this data has the production energy in kilowatt hours and also specific energy kilowatt hour per ton. But For specific energy ni more like additional information. So you for plotting a QSUM chart, it's not going to be very critical. We are more looking into production and energy. Okay. So once you copy the data, now we can start to insert our scatter plot chart, which is go to insert, and then I'm using Excel 2016. I'm not sure which one, which Excel you guys have, but hold on, yeah. Okay. So what you can do is go to insert and then charts. Make sure you select scatter, insert scatter plot, and then make sure you choose the first one. I hope you guys can see it. Is it showing? Why is it not showing? Never mind. But if you look at the what you call it, the words, the guide from the words how to plot custom chart here. Yeah, this is the first one, the one that has no line connecting the dots. So I have chosen that one. I'm not sure why my Excel is not showing on the Google Meet, but okay, once you have clicked that, now you're able to see some sort of like a blank uh, chart that you need to fill up the data. So first we need to right click on the chart and then select data, choose select data, and then click on legend entries. Make sure you click add. Okay. The series name is up to you, whatever that you want to use, you can do it later. But for series X, you have to choose, hold on, should be the production. Yeah. So we'll be using production for series X, and series Y we need to use energy. Okay. Mana hilang? Series Y should be energy. Why is it not showing the name? Let me double check with it. Okay, series X production. Okay, series Y is energy. And then you have to switch row and column 2 times. I'm not sure the logic behind this, but this is actually how it's meant to be. Tekan sekali juga. This one. So that's how you get your actual plot as shown in the, what do you call that? The guidance here. And then from there, you need to go into add chart element, go to trend line, and then choose linear, because we are trying to approximate linear equation. We are not trying to approximate exponential or linear forecast. We are more focused on linear. We are not doing mathematical statistics that much. We are just trying to figure out the best approximation of energy consumption for the organization. So just use linear. And then once you got that, you need to select the trend line and right click on it. So we'll have to select this line, the one that have just been approximated, and then right click on it, and then click format trend line. I hope everything is being shown here. And then make sure to click display equation and also display R squared value on chart. Once you click that, tick that, you can close the format trend line and you'll be able to see the equation that you're going to use for your proposal later on for your mini project, which is y equals to 426.45x, which is x is the, of course you have to do the labeling. Labeling, I think most of you pun tahu. I don't have to elaborate much lah. If you want to change labeling, you can just select, I think this one, I guess. Which one that has the label? second. Oh, this one. So, hilang pula yang tu. So, there has been, I think this one. Okay, good. Okay, so labeling, then change the name according to the ni lah, production tons, and then sorry, ni energy, and this one is production tons, and then energy kilowatt hour versus production tons. Of course, for this part, I'm not going to put it in lah because the gist of the procedure that I would like to show to you is the how to get the regression analysis. But for your mini project, make sure to title everything here accordingly to your data. Make sure the data, if the names is production tons, you have to put it in production tons here. Okay, so this equation, what it means. Okay, this one is the one that I'm going to elaborate in a little bit, which is in chapter 4, slides by Dr. Nofri. This slide is actually a bit of accumulation from first chapter to I guess fourth chapter, but I guess we can more or less brief. I'll brief you just a bit on the starting topic because starting topic is just on chapter 1 and chapter 2 only. Okay, so this is how you do QSUM chart. So QSUM chart is also what you is also reflect the EEI. It basically this is also EEI lah ni. But QSUM chart is more on the reporting period, whereby EEI more on setting up the baseline. But the workaround is the same. So for EEI, you will also use the Excel linear approximation, and for QSUM pun gunakan linear approximation of Excel punya ni, nak mudah. If not, if you want to plot everything manually, it would take some time lah and may not be accurate. Okay, so this is how you do your QSUM chart. Of course, there's a guidance already being listed here. Oh, sorry. Okay, so this equation, the regression analysis, this is the linear approximation, and this is the R squared regression value, which is okay. Later on, I'll show it to you what it meant. Any questions so far in regards to how to plot QSUM charts? The one that has not been shown is just on changing the select data. This part, switch the row and column. In the how to plot QSUM chart guidance, there's no mentioning it here, but in order for you to get this actual data, even though you have properly selected X and Y, you still need to do switch row and column. I'm not sure what's the logic behind it, but that's the only way we could get the actual plot that we want, the regression analysis that we want from the data that we have. So you have to do it 2 times. The first will jumble up the data to a single line, and then the second one will properly plot it according to the figure that we want. Any questions?
Tak ada, sir.
Okay. So if there's none, again, if you have, if you need some clarification later on when you do your mini project, please refer to this video recording on how to do QSIM chart, because chances are you will be needing to do this for your mini project, which is going to start, I believe, next week. You have to kickstart your mini project by next week to collect all the data and whatnot. And also because we are reaching the end of our syllabus next week, inshallah. There's no arah melintang, and hopefully itulah. But regardless, I've already recorded this, and also there's a guidance provided in your notes in your Google Drive. So please take a look and hopefully be able to do it for your mini project. Okay, so now I'm going to proceed with chapter 4. Okay, chapter 4 is quite a lengthy chapter, but I'm going to use only one slide, which is the one from Dr. Nofri, which is Shah Alam based. Hold on, yeah, let me turn it on. Okay, this one. Okay, so okay, did I? It's, let me open this photo. Okay, so for these slides, for MNV, you going to look at the last one. Okay, uh, there are the slides here. Okay, so for MV plan is actually the same element derived from these notes, but in a presentation it is being presented in a different manner. But I think for us, I think this slide is much more better lah, in the sense that the explanation, the way it shows its information, I think this is much better to understand. And for TC 2.3.1, 2.3.3 is the one that I've already discussed in previous chapter because it's a mix apparently. Somebody put it in together with the mix. So I've already finished it up last week, I guess. So you can have a look. But actually, everything is also being based on the measurement and verification slide here. So I believe if you look at the measurement and verification slide, would be sufficient for us to complete chapter 4 lah. So again, as the name suggests, chapter 4 is more on sort of like auditing, the one that I've discussed in the previous class for class D. But it's more on the why we need to do it, not so much on how we can do it, because previously I did discuss on how we can do it, but it's more this chapter is basically on why we are going to do it. Okay. Okay, let me zoom it in to make sure everyone can see it. Of course, you guys can also open the slide from your Google Drive if you can't see the Google Meet resolution, maybe because internet problem and whatnot. Also, my camera isn't that great, so if it's blurry, please do open your Google Drive as well. Okay, hold on. I'm trying to figure out how to make this properly show in this. Okay, I guess this one is okay. Okay, so some revision on chapter 1 and chapter 2. Basically, the reason why we are here, you guys are learning this, is because our previous Prime Minister, Datuk Seri Muhammad Najib Tun Abdul Razak, even though he has been prosecuted on the charges, but he was the one who give commitment to reduce voluntary reduce up to 40% in terms of emission intensity of GDP. Whether we have achieved it or not, I'm unable to give you the answers because we have changed the government so a few times already. So I can't pinpoint whether they are still pursuing this 40%, but apparently the mechanics around achieving this is still there. If I'm not mistaken, our newly appointed Science and Technology Minister has given some tax exemption and whatnot, I guess. So I guess and recently, if you recall, somewhere middle of this year, we have been bashed in one conference in Tokyo, I guess. Oh, sorry, UN, on our failure to meet, I guess, or maybe not progressing well enough to this commitment, 40% emissions. So that's why they started to re-engage the commitment to realize green technology and reduction of emission by 2025, I guess. Yeah, I can't recall the exact date year given by that Minister of Science and Technology, but basically we are in this because we have given commitment. Of course, there's also economic values lah. Why our previous prime minister wants to commit to this? Of course, advertisement and whatnot. But basically, we have given our commitment to achieve it last year. But whether or not we have achieved it or not, I guess we are unable to show lah. It depends on the current government punya direction. Okay, so we are facing crisis in the sense that all the energy supply that we use for our energy consumption in Malaysia basically are based on something that is finite in number. That means it can deplete over time. Let's say for gas, gas reserve may deplete, and then we are subjected to gas prices. For coal, we do not have sufficient coal mine, or even, I don't think we have coal mine in Malaysia, even though we can, but I don't think we have sufficient. So we have to import coal from overseas, and also coal is very dirty. Yeah, it produces high CO2 emission. For hydro, we are only able to have hydro in certain cases, in certain places only. For example, in Bakun and in Peninsula, I don't think we have one in Peninsula, or in Kedah, if I'm not mistaken. One or another one in Kedah. Correct me if I'm wrong. And it requires flat terrain, and it's hard to get the permit to because we need to make sure the wildlife isn't being tak diganggu lah. There's no issues affecting wildlife, because when you do hydroelectric dam, there's tons of you have to interfere a lot with the wildlife ecosystem. Going to banyak lah yang akan musnah, because we need to create a proper height of the dam, and then install a big machine so that the water can move it around, produce sufficient amount of energy. So you're going to interfere a lot with the ecosystem, and maybe destroy the wildlife area, surrounding area. So people won't, and that's why the permit is going to be hard. For nuclear, we have issues with public acceptance because, again, just recently we have Fukushima nuclear tragedy. But nowadays, I think with Elon Musk's championing nuclear technology, because actually nuclear technology is the cleanest source of energy that you can get. The cleanest, the highest amount of source of energy, the most efficient amount of energy that you could have without interfering or destroying any wildlife resources. You just locate one building remotely as possible and then connect the power line. But the issue is with safety. If there's something wrong with the nuclear, even wind can carry the radioactive to the populated area and cause radiation. Radiation similar to what you call that in the Russia, the one that we watch in HBO Max. So public perception on nuclear is still not good, even though nuclear tragedy over the years since 1940s is only 3 times, I guess, for the whole I guess almost 100 years already. Is it 100? 19 a few decades at least. So only 3 cases, but again, when it does happen, it's going to affect quite a long time lah. Macam apa nama tu, Chernobyl tu, sampai sekarang orang tak boleh nak duduk Chernobyl tu lagi. because of nuclear radiation still exists there, even though Chernobyl was back in 1960s or 1970s. The nuclear explosion, nuclear leakage happened in 1970s, but even now people won't be aren't able to still. So imagine lah if that thing happens in Malaysia, nak lari mana kan? Okay, and then renewable energy is, yes, it's good, but in order for us to change from conventional to renewable energy and then feed it up to the conventional grid line, is going to incur quite a high cost to the whole overall investment capital. And then it can be interruptible. That means you need to do maintenance. Maybe if you're using wind turbine, you need to maybe I guess there was once a case where a flock of birds causing the wind turbine not to be able to function because they keep crashing on the wind turbine. Some Einstein did say if you want to understand the world, you have to look at in terms of frequency and wave. So I guess the wind turbine produces some wave or frequency that affect animals in such a way that they are attracted to it. This is true. This is actually something of concern for technologies to implement their uh, machinery, because because when you're trying to produce electricity, you have to use DC motor. From that means it converts kinetic energy movement from the turbine into electricity using electromagnetic principle lah. So in order for it to do that, when it start to rotate and the magnet start to produce electricity, apparently there's a frequency that attracts insects quite significantly. And I've noticed this because the sensor or whatever that I'm using for my team are using for Madukulalut keep on having issues with calibration, meaning somehow the area that we install the sensor attract the bee, the lebah kelulut tu, to that particular because apparently I read it's more on the frequency issues. They operate on the frequency, and that frequency produced by our sensors attracted them to the area and resulted in our sensors not being able to work properly. So the same thing goes here. So there are certain cases, especially in wind turbine, may cause issues with wildlife in such a way that it affects their, I guess, day-to-day operation because the frequency introduced by the operation of the machine. But for solar panel, maybe musim tengkujuh macam kat Terengganu sekarang ni, there's not enough sunshine, so the energy being produced can be interrupted. It's not consistent. And also at the moment, the capacity is quite small, but I don't think this is true, especially for solar panel that nowadays is quite efficient. And also the technology behind our renewable energy right now nowadays is very good efficiently in terms of efficiency. So this is subjective lah, small capacity. I believe the one that we have in Terengganu, in Juatan Dungun, is quite huge, which is 1 megawatt, enough to power up the whole Juatan Terengganu building for free. But of course, that is projection. The actual energy consumption, energy produced has to be observed from audit process lah, which is the one that we are trying to get from BPF for your mini project. I'm not saying that you're doing the work for us. It's more like for us to see whether having solar panel installed in Juatan Terengganu does help with our energy consumption overall. Okay. So I'm telling you this is brief, but apparently membebel juga. So okay, never mind. We move forward. So this is the load duration curve for 2012. Apparently, but basically what it's trying to show to us is that rather than using normal practice without introducing tons of incorporation of investment of capital in renewable energy, we can actually achieve the reduce energy consumption by just slightly adjusting or modifying our operation time, scheduling or whatnot, which is in this case maximum demand lah, from participation side, which if we are able to do that from operating at peak hours, we change it to operate at during non-peak hours, we can also reduce the Malaysian load duration for the whole year, for the whole not year. This one is for the whole day. Sorry, this is day because this is hours. Okay, and also towards achieving sustainable energy efficiency, Malaysia has took initiative in implementing several steps. For example, NKEA, where we implement energy efficiency on government building and also government related transactions. So any kind of incentive on small capacity appliances installed in Malaysian government punya building will have sales punya incentive. That means sales tax tu murah sikit or exempted. And then it also promote the use of electrical appliance with minimum energy performance standard, which is MAPS, the one similar, I guess, to the one that we discussed in chapter 2 that has energy star labeling for masses, but for government building, they be using MAPS, MEPS. And also, Malaysia has promoted uh, the build-up of energy efficiency building. For example, here in low energy office, I'm not sure which building is this, but this one is in Bangi for Suruhanjaya Green Technology, GEO. And Diamond Building here is in Putrajaya. If you're able to, if you have been in Putrajaya, it's the one in parcel 2, I guess behind TM building, I guess. Maybe I'm wrong, but you can see it quite or maybe this is the TM building. Not sure, but this is behind around Palace of Justice punya area tu, belakang tu, I guess you can see there. So Diamond Building ni allows for natural lighting. So if you went there during office hours, chances are you won't be able to see light being turned up because everything is being lightened up by naturally. That means they don't use switches. It only turns on at night, but during the day, it's almost like an empty building lah. But actually, people are working there because it allows for natural lighting, so they don't have to use electricity. Okay, and okay, for government building to measure their energy efficiency, they also use energy audit and retrofits to make sure that the energy savings are being identified. And they have been monitoring 5%. They have been able to monitor an amount of 5% savings on electricity bill for total of 25 ministries building. Maknanya bangunan kat Putrajaya Parcel 2 tu, Precinct 2 tu. Overall, they are able to see 5% savings on each of the 25 ministries building. So which is quite huge. 5%, even though doesn't sound that much. Yeah, Fatin Nur Anis, ada soalan? You raised the hand. Or did you accidentally push the button? I guess she accidentally pushed it. But basically, based on their observation, they found out, or auditing, they found out that they are able to save 5% of saving electricity. And also, they are striving to achieve EMGS for each of the building ministries. But of course, again, due to the change in political scenery, EMGS ni maybe they put it back on the back burner lah, considering nowadays people are struggling with COVID punya survivability and issues with economy. So I guess EMGS is the least of what they are striving for today lah. But during the UN meeting just this year, I think they are going to work on it lah. But for now, yeah, this may not be their main concern, but the structure, the mechanics to achieve this is still there. The building is still there, but of course, we have yet to see lah any kind of strive towards achieving this EMGS for government building for now. And in order for them to realize this, rather than they spend our tax money directly towards improving the electricity bill, they actually use the energy performance contract approach. That means they hire private company contractors lah basically to engage with the contract for them to give, install, maintain, and acquire all the installation of renewable energy or any kind of energy efficiency implementation to the government building without having to fork out huge capital. That means the government don't use our money to implement, of course, dia punya words, they don't use it lah, but kita tak tahu lah kan. But basically, this approach means that the private company fork out their income, their capital, and then they maintain everything for a certain period of time until such the day that the contract has been completed and all the energy saving can then be realized by the government themselves. So it's a win-win situation. The private company able to survive using contract with the, of course, with the untung meniaga tu, and the government are able to save the electricity bill, reduce the cost of operating their buildings without bila indirectly, if they don't have, or if their own building does not produce consume that much energy, so Malaysian government don't have to import that much of bahan api. But at the same time, after the contract period has ended, not only that, Malaysian government can also realize savings in paying the monthly electricity bills after the period of contract ended lah. So they're using the energy performance contract approach, where the financing concept is that it uses the cost savings of reduced energy consumption to repay the capital investment for the installation of energy conservation measures that it has been forked out by the ESCO, Energy Service Company. Okay. So this is the mechanism how it works. The first year before electricity ECM is being taken. ECM is again energy conservation measures. Before auditing, before EE, before AMAS, everything, the whole month, the whole amount of electricity bill has to be paid by their own pocket, Malaysian own pocket. And after the implementation of EPC contract, for a grace period, all the capital that needs to be used, that has been used, will be repaid using the savings, meaning you pay the electricity bill still at the full amount, but you're paying it directly to ESCO, and maybe due to the arrangement made by the government and the ESCO, the government are also taking some of the saving that has been granted. So that means the electricity bill only paid, maybe they are still paying full, but the half that is being saved, half of it is being given to the government and half of it is being given to pay the ESCO. And after the contract period between government and the ESCO ended, the full saving of the electricity bill can then be put back into the pocket of the government, and then can be reused to another area. Ideal cases actual cases, I don't know how the implementation goes, but I don't think this savings going to be, nowadays, is it that huge? I'm not sure, because they are not working directly on, they are not revealing the data. It's not open book, or maybe I'm not the one I don't have access to it, because again, This is more on government expenditure, and anything related to government, chances are it has its own private and confidentiality punya clause lah. So I'm not at liberty to say lah, even though I work for government. Okay, so what does the EPC generally includes? It includes identifying opportunities to implement ECM. ESCO also come up with a plan to formulate what kind of technical details that may be needed in order to install. And then ESCO install, and then any kind of warranty issues, maintenance or whatever is being maintained by ESCO lah, during the period of agreement lah, between the client side and the ESCO. I guess normally it's after the contract period has ended, chances are maintenance, the facility owner has to do it on their own lah. So that means during the contract period, the facility owner needs to take note on how to maintain, on how to service the equipment, the ECM measures that has been taken. If it's solar panel, if it's power plant, if it's nuclear power plant pun, they have to learn on their own how to maintain it or troubleshoot it. Okay, so the beauty of it, the owner, from US perspective, because US has implemented this on their side quite a long time compared to us, they have the experience. So from US point of view, the owner does not have to come up with to fork out with a huge capital for their energy efficiency project. So it's a huge bonus lah, because now without even spending cents, ringgit and cents into the project, they are able to save the electricity bill. So and they have their own project management, provides owner project management. So EPC doing ESCO is the one who's doing the project management for the owner, the building owner. So that means the owner don't have to concern themselves with any issues with deliverability. And engineering design and evaluation will create savings for the owner, ECM installation, and also performance. Contracting is being done by ESCO, measurement performance pun being done by ESCO. However, of course, this is ideal cases, but in real life cases, there are ugly side of EPC where the contractor has issues. Maybe they don't have the experience, or maybe they hire another contractor to do it for them. Ni typical lah Malaysian punya style. But even so, that means bukan Malaysian. This is US experience. That means even these things, hire contractor is actually a very common theme lah in any kind of industries. So it also happens in US where the project we are given a bad project management, so deliverability is bad. Bogus engineering, that means they made up most of the design and whatnot, so it doesn't work when everything has been installed. Too many subcontractors get involved because ESCO acting more like a brokerage, not so much as the one who's doing it. But I think in Malaysia, it is the same case, but the contractor, the ESCO that we have approached for 8am-10am is actually the one who installed it, which is good lah. And it's a local company. So I think it's good, but and you can see it already been installed 8am-10am, so it's a good thing. Bogus monitoring, that means they create their own, when they did measurement and verification, the report is actually extremely, not to say conservative, berlawan konservatif, terlalu positif. That means the data tu dia main lah, dia manipulate. Ni normal kalau ni, tapi it is expected. People, some sense which we will going to elaborate later. There are some data that you have to approximate, but it is advisable for you to make it conservative when doing measurement and verification, so that the saving that you get from that measurement and verification, even though it's not accurate, but at least it does not overinflate the actual data. So bogus monitoring, sometimes they don't even go down to the site and they just give some numbers to their report, and apparently the saving isn't that much, but the data shows that there's actually savings being done, which is not good. No ongoing maintenance and also argument between ESCO and building owner. This one is expected, but this is EPC issues. So in order for us to do this, to handle this, it is advisable for us to engage a third-party verification. So this one, third-party verification, is the energy manager pulling issues. That means if the building owner has their own energy manager, they can appoint internally. But if not, it is best that for MNV, you engage professionals. There are a few companies that provide third-party verification for energy between building owner and the energy service company, so that the data is actually reflect accurately and does paint the best picture for the energy conservation measures that has been installed. Okay, so that argument between APC and building owner can be handled quite can be more on the truth rather than assumptions. Okay, so before I proceed with measurement and verification, the actual slide for chapter 4 ni, I would like to take a break for maybe 5 minutes before we proceed. So okay, now my watch is at 8:47, so 10 minutes lah. I guess around 8 or 9 o'clock lah. 9 o'clock. Is it 9:55 lah? 9:55. I'll continue with the lecture. Okay, thank you. Okay, can we continue? Is everyone all right? Good. So the faster we start, the quicker we end the session. Okay, so but the thing is, I'm not going to cover the whole chapter 4 today because it's going to be quite substantial, and I guess, we'll be separating these slides into two. So today I'm going to cover up until slide 30, I guess, and then continue the next class, the same with Sir Azri. And hopefully by next week's Sunday, we'll be able to finish our chapter 4 and therefore our syllabus. Okay. So measurement and verification is actually the same as is some sort like a repetition for those who did focus on what I've been mumbling about last few weeks. It's actually more or less the same, except that this time around for chapter 4, we are more focused on why we're going to need to do MNV. So that's it again. It's more or less again me babbling about on apa ni lah, theoretical parts. So what is MNV? Basically, it's just a process of using measurements to reliably determine actual saving created by either an individual facility or even the whole organization by an energy management program. And this excerpt is being taken from International Performance Measurement and Verification Protocol, IPMVP, which is what Malaysian government has been using as guidance. And why do we need it? Because for the organization, the executive may want to know how much they have saved, for how long their savings will last. For project partners, maybe ESCO, maybe the contractor, to prove that the energy savings projects has been successful. And for the ECM aspects is that to quantify the performance of the proposed ECM, and measure and verify the energy savings. And finally, for savings perspective, project with strong MNV result will result in substantially higher level of saving. So this is the reason why. And who should use MNV? There are four: building owners, ESCO, the energy policymakers, especially the Energy Management Committee, and also any kind of person who is involved with greenhouse gas emissions performance of renewable energy projects and demand side of management programs. So basically, anybody who's involved with environment issues lah. So these four person may want to look at your audit report lah. So MNV is usually being done whenever there are savings that need to be verified. When we are talking about savings, again, it's cost and cost in terms of ringgit and cents. So it is being used in the context of energy efficiency, energy performance contracts, regulated EE programs, and also whenever the owner of the building wants this verification for their own internal accounting purposes. Maybe dia nak buat in-house punya auditing ke, nak make sure all the in finance auditing. So if it requires for them to look at the capital being spent or savings being incurred, savings being accrued for the year, so they may want that MNV result. So you in a year maybe one or twice lah, typically depending on whether or not the MNV duration for project ECM for energy management auditing to coincides with the organization itself punya internal accounting. So if not, then if sekali, then maybe you need to do MNV to only once a year. But if it does not coincide, then chances are you have to do MNV twice a year, depending on the internal accounting punya arrangement and also your energy reporting, energy consumption reporting to SNT, Suruhanjaya Tenaga punya period duration. Okay, so there are four protocols that you can use, but typically for Malaysia, we look into IPMVP, and you can also refer to a share guideline 14 and USDOE, FEMP, MMV guide, and also California Energy Evaluation Protocol. But I guess for the two bottom here is more applicable to US, and a share guideline is, I'm not sure where, I haven't had a look into it, but IPMVP is mostly what the world use lah. IPMVP is also the one that Malaysia is referring to. Okay, so if you want to look at whatever IPMVP is, you can have a look at their publications as listed here, and you can download it from evoworld.org. So I myself, because I'm not a practitioner, so even though I have the license of energy management, but I do not practice it, so I haven't had a chance to have a look into IPMVP documentations here. But if let's say you do want to have a career setting up your own company and consultation for energy management, you need to be you need to have this as your, orang kata, bakar, rebus minum air dia. You have to be able to do this for these publications kena hafal betul lah. Okay, so what is the purpose of MNV? Again, reiteration, it's basically to increase energy savings, to document any financial transaction as a proof, to enhance financing or for efficiency projects, to improve score in GBC if your organization are heading towards that, to manage energy budgets, to improve design, operation and maintenance of the building and also the equipment, ECM, support evaluation and regional efficiency program, and also to educate the public about energy management. But educating ni is more like indirectly, but having something that is physical, like the one diamond building in Putrajaya, is actually quite a good sebab people can see that takkan office ni kosong ni, punya cantik kan, tapi bila nampak, bila tengok betul-betul, tengok ada orang is working in that environment, so it shows to you, oh bagus ni building ni, indirectly lah. I'm not saying people everyone who sees that building will say the same things, but people can conclude if more easier if they can see it, because they did say seeing is believing. So educating public ni is more like indirect result of having a big building that has energy efficiency implementation on it. Okay, so there are 6 principles of MNV that you need to observe, which is the reporting of energy saving must be complete in regards to all significant effects. It is relevant to the saving. The saving measure should be relevant to the parameters that may incur the savings, and any parameters that are unable to be quantified or maybe less significant should be estimated. And all MNV activities should be transparent so that there's no doubt can be raised. Consistent, that means all the reporting must take consistency between types of energy efficiency project and energy professionals, and also the periods of the MNV implemented. Accurate, so the accuracy should accurately reflect the budget being given, and also cost should be small to relative to the cost of the MNV cost itself should be small in regards to the overall ECM cost. And conservative, this one is the one that I've mentioned earlier, where any kind of saving calculation or procedures should be designed to underestimate the saving. That means it's some sort like prepare for the expect the worst, but prepare for the worst, expect the best, something like that. So if you're able to save, if your data shows you might have possibility to save let's say 60%, try to work your MNV in such a way that it reduce the expectation to maybe instead of 60, now go to 40%. So that whenever you report, you got 40% saving, but in actual account, the money coming in, apparently it's actually 60%, for example. The saving is actually 60%. So it reflects better on you so that you don't, and beside, for the next year, you don't have that pressure to achieve the same 60% or more. Ini memang typical reporting punya issue. I think it's also applicable for business punya schools. When you graduated nanti, when you become your apa nama, when you're working with someone, it's typical for people to report to you and conservative values compared to the actual values being if let's say savings lah, or return or business returns ke apa ke. Typically, I'm not sure for transaction. For actual transaction of a business, yes, you need to be more accurate. But for reporting or maybe budgeting, people tends to budget conservatively, to report their budget conservatively, but the actual budget themselves, when they realize it, chances are it is more inflated. It depends on environment, but for MNV, for energy management, we want conservative reporting so that next year tak perlu nak achieve that 60%. We just go for the 40%. If it's exceed 40%, it's good, but at least it does not fall below 60% when we report. Okay, and then fundamental concept of MNV is that the concept for energy saving, it is impossible to measure something that is no longer there. So energy saving is actually unable to be measured directly. So because again, it has already happened, you can't go back in time to measure the actual value. So therefore, we must compare with the baseline after we've implemented it and compare it with the one that we have data of for the after the retrofit. That means retrofit meaning after you've implement the ECM and the data that you have collected after the implementation of ECM tu lah. Sorry ayat saya berbelit. But basically we need to compare baseline, the one that we have recorded before the implementation. We have to compare it against the one that we have measured after retrofit or implementation of ECM. The keyword here, yang lain-lain tu tak apa, because saya pening dengan apa saya cakap, but the keyword here is measurement. You have to be able to measure. There's no point of saying we are able to save this amount of this amount of that, if there's no figures, if there's no numbers. So the keyword here is measurement. Okay, so the basic equation is that you have a saving is actually baseline energy the previous year before you install the ECM minus the reporting period after you have installed ECM, plus minus any kind of routine adjustment and also any kind of non-routine adjustment. So what is routine and non-routine? Routine and non-routine is after this, but for adjustment is basically to distinguish proper savings report from simple comparison of cost or usage. Basically, adjustment is some factors that may influence the energy savings for that year or for that reporting period. So for proper report savings, adjustment must account for the differences in the condition between the baseline and reporting period, because maybe certain year, like for example, especially last year 2020 compared to 2019 is going to be very different, your energy consumption for that year. For 2019, maybe the energy consumption is up there, maybe few thousand kilowatt hours. But in 2020, due to pandemic, people don't come into the office. The factory is supposedly being shut down. So energy consumption is going to be very hugely underestimated undervalued. So that means This is what it meant by adjustment that needs to be made. So you must adjust the baseline, which is 2019, to reflect the energy being used in 2020, because it's, of course, if you're just using 2020 data as it is, memang semua orang dapat lah apa AMGS 3-4 star tu, tapi what's the point, because that actually does not reflect the actual story of the energy consumption. So that is what adjustment is being mentioned here lah. So conditions commonly affecting energy use, such as weather, occupancy, plant throughput, and equipment operations, are the one that we need to make an adjustment for. And adjustment can be trivial, it can be simple, or it can be even a complex engineering calculation, depending on apa ni lah, your nature of the business, nature of the adjustment that needs to be considered. Okay, so for example, in this case, the baseline energy, this is the one that I've just discussed just now, which is maybe this is 2019 and this is 2020. And because of COVID, so 2020 tu baseline energy ni need to be adjusted lah. So either increase it in regards to normal operation as compared to 2020, or bring it down depending on the actual adjustment that you need to be made. Okay, for the actual adjustment ni, you guys don't have to worry that much, because it's more on the next stage of practitioner of energy management. But for now, just know that for MNV framework to work, MNV reporting that needs to reflect the actual story, it involves the baseline being moved around. That means the data in baseline needs to be adjusted as compared to the reporting period punya data lah. 2019, 2020, so 2019 because of COVID, so 2019 punya data ni kena adjust lah, either increase or lower it according to the adjustment that needs to be made. So for in this case, the production increased during the reporting period. So if you take it as it is, it seems like reporting period waktu in this case example ni macam tinggi sebenarnya kat sini. Okay, ni yang orange line ni tinggi sebenarnya, tapi actually it is because production increase, because demand tinggi. So what you need to do to reflect the actual saving, the baseline energy ni should also be adjusted to the same area, because baseline energy is when normal operation, but apparently for this reporting period production increase. So kalau compare apple to apple tak boleh lah, compare directly tak boleh lah literally, because the data is not operating at the mean value, at the same mean value, average value. So some adjustment being made where the baseline is adjusted to a new level, and then you can compare it apple to apple to get the actual energy saving for that period. Okay. So, okay, this is the one that I would like to explore just now, which is routine. What is routine and what is non-routine? So, routine adjustment is basically something that is happen almost expectedly. So, weather expected monsoon, production volume can be expected provided there's a trend on it. Maybe your toy shop, you need to produce toys during Christmas, ramai orang beli barang toys, Boxing Day sale apalah, so you can almost expect production volume. Ambient temperature, again depending on the seasons, can affect your production. So it is independent variable, yes, but it is expected kind of independent variables. But non-routine adjustment is something that happens without expectation. Like for example, flood, fire, unanticipated, and also non-routinely adjusted base static factors, such as suddenly you want to renovate your building, so everything shut down, so of course energy being used reduced. Weekly production shifts, changes, or type of occupants changes because of COVID and whatnot. So not COVID lah, holiday season. Holiday season, you can expect the building to be almost empty during Hari Raya ke, Christmas ke. So That is actually maybe sebab raya kan dia berubah-ubah. Sometimes it's June. This year I guess it's June. So next year mostly May, and then the year after that April. You are expecting it, but it's kind of non-routine lah, because this year March working, and then suddenly next year March is Hari Raya. So something like that lah. Okay, and in order for us to relate the variables for this, whether to find out the relationship between adjustment and also the what you call that, the baseline punya equation and the reporting period punya equation, you have to perform regression analysis. This one is the one that I've just explored, I've just briefed to you earlier in this class, which is the Q-sum chart, Q-sum, cumulative Q-sum chart. So the relationship between these two or more variables are called regression analysis. So regression analysis is the one that we explore the relationship. Again, I would like to remind you the equation that we got from the Excel sheet. The y equals to mx plus c tu tadi tu. Not the r squared. R squared tu sebenarnya is actually a relationship juga. But for the one that we are talking about regression analysis is actually the both of them. The relationship considers the association between the variables, but may not necessarily show cause and effect. It's maybe causal, but not cause and effect. So in order for us to do that, we have to perform mathematical modeling. So in order for us to do mathematical modeling, we have to properly define the y and x of the equation. So that means the y is the dependent and x is the independent, because y equals to x, not x equals to y. If y equals to x, that means x can be independent and y must be dependent on the value of x in order for it to get y. So therefore, in this case, the dependent variable is the energy and the independent variable is the weather that affect the energy, but the energy does not affect it. Occupancy. The occupancy does affect energy consumed, but the energy consumed does not affect occupancy, production volume, and also time lah. So again, time is the ultimate variable. That means because nobody can control time, we can only mitigate, we can only schedule, but we can't turn back time, we can't manipulate time. So time is the ultimate independent variable. So this is the one that we had just done, but of course this is a different data, but this is specific for industrial, where industrial example where the relationship of production with energy use, where it shows the relationship between production and energy use. So if you recall, I also using Excel, I'm also able to produce this kind of equation where the R squared is actually the accuracy of the correlation between energy use. So that means, yes, this is an estimation. The y equals to 1.0 something is actually, this is the relationship, but predicted, but the accuracy is dependent on, is being shown by R squared. That means as if it's closer to 1, that means this is accurate. So you can take y equals to 1.09 at face value, almost at face value lah. But for if like say the one that I've just shown to you earlier this class, it's at, if I'm not mistaken, 0.7 something. So it's not that accurate. So you might want to consider some adjustment lah. In this case, because R squared is 0.9, so it's actually almost very accurate. So there is still some adjustment needs to be made in order for you to calculate the actual savings, but it's almost minuscule because R squared here shows that this equation is almost very accurate. Okay. And this is another example for building. As you can see, this is almost the one that we have gotten, which is at 0.78. So not that accurate. So the adjustment that needs to be done here might be quite substantial. So in this case, this is an example of office building where it shows the relationship of number of working days. So that means the occupancy rate versus the energy use in a month. So as you can see, number of working days, if there's less people occupying, for example, in September 2010, it shows only 20 days of working. So that means out of a month, if let's say September, how many? September. September has 30 days. Okay, so 30 days minus 20, so that means 10 days people are not occupying the office. So as you can see, it's almost the least amount of energy being used, or except for this one, February, where it's only 18 days. So the second least amount of energy being consumed is at September, because there's a relationship between occupancy rate and energy consumption. And it shows here, which is 0.7, isn't that bad, but it's not as accurate as 0.94 lah. So R squared, what you can conclude here is that the closer R squared gets to 1, the more accurate your linear approximation is showing, and the lesser adjustment needs to be made lah, if you're able to get it closer to 1. Okay. So in this case, there is a relationship between a number of working days and the consumption, but it's actually indirectly, because it's more on occupancy rate rather than number of working days. Because even though number of working days is just 18 compared to 20 in terms of September is 30, but there still the chiller may need to still operate, because if it's not operating, takut rosak pula, berkarat apa semua. So there is a relationship between number of working days, but it's not that accurate as compared to occupancy rate. Okay, so what kind of option that you can do? Okay, so for this option, for this slide, it's actually a repetition of previous slide that I've just discussed last week, which is whole facility and retrofit installation and whatnot. But this one, I guess I'll be saving it for the next class, so that Sir Azri pun boleh revisit balik benda ni properly. So I guess for today, tu je lah kot, cover until regression ni, because we did explore Houston chart just today. So I guess it's kind of apa ni lah. Hopefully you guys boleh nampak lah what's the use of the equation that is being made. Basically, the conclusion is that it shows the relationship between variables, and you can use it to predict the energy savings later on. Okay, so any questions before I end the session for today? Okay, so thank you for the feedback. If there are none, then I guess we can